Hello everyone, myself Aswin Chauhan. Welcome you all to next part of data science series. Today we are going to discuss k-mean clustering and analysis. Overview for k-mean clustering. What is k-mean? K-mean clustering is an K-mean clustering is an unsupervised learning algorithm that aims to partition data points into distinct clusters based on their proximity to cluster centroids. It interactive assign data points to the closest centroid and recalculate centroid position until convergence is reached. Key concept. Key concept. The algorithm relies on the concept of Euclidean distance to measure the proximity between data points and centroids. The number of cluster denoted by k and is a user-defined parameter that influences the resulting cluster. Practical application of k-mean clustering. Customer segmentation, image compression, anomaly detection, document clustering. Customer segmentation. K-mean can segment customer into distinct group based on purchasing behavior, demographic, or other relevant attributes. This also business. This allow business to tailor marketing strategy, and product offering to specific customer needs. Image comprehensive. This technique can be used to compress image by grouping similar pixels into cluster, reducing the amount of data required to represent the image. Anomaly detection. K-mean can be used to identify outliers or anomalies in the datasets. Data points that are far away from their cluster centroids can be flagged as a potential anomalies. Document clustering. This is the method can be used to group document documents into cluster based on their content similarities. This is helpful for organized large document collection and facilitating information retrieval. Now let's demonstrate the k-mean clustering using the Python language. Okay. So first of all, what we have to do, we have import libraries. Start by importing necessary library like sklearn cluster for the k-means algorithm and matplotlib for plotting the graph for visualization purpose. Second, load and prepare data. Load the data set and prepare it for clustering by scaling and transforming feature to ensure consistent scales. Third, implement k-mean clustering. Instead, a k-mean object with the desired number of cluster k and fit the data using the fit method. Fourth, visualize result. Visualize the cluster using scatter plots or other approximation method to understand the data distribution and cluster separation. So now let's move to our program to understand. So here is the program of k-mean clustering where we import a necessary files to our program, and these are the sample data for performing k-mean clustering. Here we perform a method and PLT scatter title x label and y label is used to mm, making a graph in for the clustering. So here is the output of this program. Here k-mean clustering, the output of program is. Now let's discuss evaluation of clustering result. Silhouette score measures how well a data point belongs to assigned cluster based on the distance to other cluster. Inertia represent the within cluster as sum of square errors WCSS indicating the compactness of the cluster. Adjusted rand index measure the agreement between the clustering result and a growth truth if available, evaluating the accuracy of cluster. Here, so this is the program of evaluation result. Here we import a necessary file which is required to generate the program. Now we use print function to print a value. Here we are assuming a ground truth level are for printing the data. Now we make a graph using the plot function and title the graph, and here it is the output of the above program. So it is the output of this program. Now let's move to our topic: challenges and limitation of gaming clustering. Outliers. Outlier can heavily influence centroid location, distorting the cluster. Non-spherical cluster. K-mean assumes spherical cluster which may not accurately represent data with complex set. Determining K. Selecting the optional number of K cluster K is crucial and often involve trial and error or using method like the elbow method. Initialization. The initial placement of centroid can impact the final clustering result. Technical like K-mean plus plus can help address this. Conclusion and future consideration. K-mean clustering has proven to be a valuable tool for data analysis and has application in various fields. Its ability to identify pattern and group similar data points make it popular choice for tasks such as customer segmentation, image compression, and anomaly detection. While challenge exists, ongoing research and development are exploring more robust clustering algorithm to handle complex data structure and non-spherical cluster. Thank you for watching the video. If you have any doubt, then comment in the comment box.